Question number 1. Estimate the question mark figures in the following data. Taking only essential elements, will form a table that contains the values of x and y. We'll construct a forward difference table till delta cube f of x. For finding the value of f of 3, the formula is a plus hu is equal to 3. By this, we will find the value of u is equal to 0.5, and applying Newton forward difference formula, f of x is equal to f of a plus u upon factorial 1 delta f of x plus u upon factorial 2 into u minus 1 delta square f of x plus u into u minus 1 into u minus 2 delta cube f of x upon factorial 3. Using this formula, we will find the value of f of 3, that is 27. And again we have to find the value of f of 5. Then we will use this formula only, but here the value of u will be 1.5. And the value of f of 5 after calculating will be 125. Question number 2. F of 6 is equal to what if the data set is given where delta cube f of x is constant? We'll solve this by Newton backward difference method, as we have to find the value of f of 6. We'll construct a difference table till delta cube f of x. For finding the value of u for difference forward Newton backward difference, the formula is a plus nh plus hu is equal to 6. Using this, the value of u will be 3, and the value of Newton backward difference is f of x is equal to f of a plus u upon factorial 1 mu f of x plus u into u plus 1 upon factorial 2 mu square f of x plus u into u plus 1 into u plus 2 upon factorial 3 into mu cube f of x. Applying this formula in f of x, that is f of 6 here, we'll get the value of f of 6, that is 126. 3. Estimate the numbers of winners having Diwali gift vouchers between rupees 1000 and 1500. Here the table is given which is not equidistant, so we cannot use Newton forward or backward method. So here we will use Lagrange's method. Range x values is in form of range, so we will use midpoint of each range as x, and for y we will divide number of winners by corresponding gift vouchers. Through this we will construct the table, that is x is equals to 200, 750, 1500, 2500 and 3500, and y will be 15, 8.5, 3.6, 1.5, 0.65. Applying Lagrange's formula, we have to find between 1000 to 1500, so we have to find the f of x of 1250. Solving this using Lagrange's formula, our answer will be 4.8111, that is 4.8. Question number 4. Apply the techniques of different table, locate and correct the error in datasets. Here the datasets is given and we will form a difference table using this. Here it is the forward difference table till delta to the power 5y. The last values are minus 20, 30, minus 20 and 10. Through this we can see that there is some error, that is in delta cube y 398 is not in the range. So the error is in fifth term, and so we can calculate the error, that is 4, using minus 5e is equal to minus 20, that is 4 number of terms or 4 numbers error. So the values of y5 should be 65540 minus 4 is equals to 65536. So the correct fifth term should be 65536. Using this, there will be no further error in this question. Question number 5. Write algorithm for Newton's interpolation. Construct the difference table and also find first, second and third derivatives from Newton's formula. The algorithm is as follows. Read n for I is equals to 1 to n. Read xi, yi and for j is equals to 1 to n minus 1. For I is equals to 1 to n minus j. If j is equals to 1, dij is equals to ji plus 1 minus yi. Else dij is equals to di plus 1 j minus 1 minus di j minus 1. For j is equals to 1 to n minus 1. For I is equals to 1 to n minus j. Print dij, print n. The first forward difference is delta f of x is equal to f of x plus h minus f of x. The second forward difference is f of x plus 2h minus 2f of x plus h plus f of x. The table is as follows. Now finding the first and second derivative, that is first derivative of Newton's interpolation is 1 by h into delta y0 plus 2u minus 1 upon 2 delta square y0 plus 3u square minus 6u plus 2 upon 6 delta cube y0. The second difference derivative is 1 upon h square delta square y0 plus y minus 1 delta cube y0.